Hey everyone, we are going to kick off Unit 9 today by talking about direct and inverse variation. Direct variation we actually did talk about back in Unit 2. Direct variation is when you have something that looks like this, when it's, and k is a constant. So we talked about direct variation, for example, if I wanted to know how many tires were on the lot of a used car sales lot, I could go around and count each tire, 1, 2, 3, 4, 5, or I could say each car has 4 tires, multiply the number of, which is our constant, and then multiply the number of cars by 4. That would tell me how many tires. But today we're going to introduce a couple others. We're going to look at inverse variation first. So an inverse variation can be modeled by any of these values, or any equations, excuse me. The middle one there, the y equals k over x, that's the one that is most commonly going to be used. And when something says that it's an inverse, I'm going to write it as y equals k over x. So whereas direct was that constant of variation is being multiplied by x, now it's being divided by x. That's the only difference, is that it's dividing instead of multiplying. So it says, suppose that x and y vary inversely. X equals this and y equals this. Write the function that models the inverse variation. So all I'm going to do is plug in these values, and I'm going to plug them into y equals k divided by x. All right, so I'm going to have 1.4 equals k over 0.3. And then I want to solve for k. I want to know what that constant of variation is. So I'm going to multiply both sides by 0.3. Now, when I multiply both sides by 0.3, I'm going to do 1.4 times 0.3. That gives me 0.42. But this is not writing the equation. This is just finding the constant. So to write the equation, I actually need to plug this in to my equation up here. And I'm going to get y equals 0.42 over x. My final answer should have a y and an x in the answer to be complete. And that's it. That's all that we're doing here. So try this one. Start by finding the constant of variation, and then write the function based on that constant of variation. All right, so when we plug in 4 for y and 7 for x and solve for k by multiplying by 7, I get that my constant of variation is 28, which means that plugging this in, I get y equals 28 over x. Let's look at another type of variation, and it's called joint variation. So joint variation is basically saying, okay, we don't just have to have x and y, we can have more than one. We can have a few different letters. We can also have a z in there. And so these are going to be some examples. We also throw a w in there. Don't be confused though, because the k is always going to be, in this case, going to be the constant when we're looking at this formula here. So it says that z varies jointly with x and y. And so I can see that it's taking a constant and multiplying it by 2 things. It could also be by 3 or 4 things. It just jointly means that there's more than one thing that's being multiplied, so 2 or more. Then we've got, for the next example, that z varies jointly with x and y and inversely with w. So jointly means 2 things being multiplied, 2 or more, and then inversely means divide. So that's why we've got k times xy, but then if I look at it, I've also got my constant divided by w. So there's that inverse variation. For the last one, it says that z varies directly, so that means that just a constant times x, and inversely with this product of wy. So you can see that if I look specifically at my constant of variation is multiplied with one variable, which is direct variation, and then it's divided by this, and that is my inverse variation. So now we're going to start taking these kind of words here and saying, what would that actually look like? So just a second. All right. So if I wanted to think about this one, it says that the mass m of a moving object is related to its kinetic energy k. So sorry that one is k in this case, and its velocity v by the formula m equals 2k over v squared. So in this case, k is not the constant of variation. They actually told me the constant of variation is 2. And then they want us to describe the relationship as a combined variation. So I'm going to look at how the constant, or 2, is related to each of the variables. So if it's being multiplied by one variable, which kind of variation is that? Direct, joint, or inverse? It's direct variation. And then 2 divided by v squared, is that going to be direct, joint, or inverse variation? It's going to be inverse. So my final answer would look something like this. M varies directly as the kinetic energy K, or with the kinetic energy K, and inversely with, sorry, I should have put with instead of as, the square of the velocity V. So I would look at, there are two different variables that should be represented, K and V, and I've got the direct, I've got the inverse, so we're set there. All right. Now this one might look a little tricky because of the parentheses with the adding, but think about how the 1/2 is relating to each of these terms. Try this one on your own and see what you get. Okay, so since we have 1/2 multiplied by two different things, we have 1/2 times h and then 1/2 times that set of parentheses, this would actually end up being joint variation. So we would say that A varies jointly with the height and the sum of the bases. Now, something I want to point out to you is that we never mention the value of the constant. 1/2, 2 was not mentioned down here. We're only talking about the variables. So here, sorry, here we just say that the variable that's isolated, varies, and then jointly, because there's more than one thing that 1/2 is being multiplied by, varies jointly with the height and the sum of the bases. So that's it. That's our introduction to inverse, direct, joint variation. If you have any questions, let me know.